what is Hooke's law in shear? If we draw the shear stress strain diagram, that is, this is shear strain and this is shear stress. That is like normal stress strain diagram, the initial part is straight line, and if say this is the proportional limit P, then up to proportional limit shear stress is also proportional to shear strain. That is, we will introduce one constant here, G, and G is tau by gamma, shear stress by shear strain, where G is called what? G is modulus of rigidity or modulus of rigidity or shear modulus. Now what is bulk modulus? Bulk modulus K is the ratio of uniform hydrostatic stress by volumetric strain. The definition of uniform hydrostatic stress is, that is, sigma x is sigma y is sigma z, all three direction stresses are same, which is compressive in nature, and that is minus P. So from this we can write K is minus P by volumetric strain is E. So this is the definition of bulk modulus. So this is the definition of bulk modulus. Now the next point is Poisson ratio. What is Poisson ratio? That is determined by mu. Poisson ratio is the ratio of lateral strain by longitudinal strain. Now let me explain Poisson ratio by this configuration. The dotted line shows the initial configuration of the component, and the bold lines or continuous line shows the final configuration of the component under action of a force P. And you can see that along x direction, force is along x direction, that is the longitudinal direction. The dimension has been increased, and in perpendicular direction, that is y and z, the dimension of the component has been reduced. That is, lateral strain is what, and longitudinal strain is, that is epsilon x, and lateral strain is minus epsilon y. Minus sign or negative sign indicates what? Because Poisson ratio is always positive. This is a ratio, this is always positive, and the dimension of the component in lateral direction has been reduced. That is, this is in compression, that is negative strain, but Poisson ratio is positive. To make it positive, the negative sign has been introduced, and that is also equal to minus epsilon z by epsilon x. So Poisson ratio mu is nothing but minus epsilon z by epsilon x. Now what is generalized Hooke's law? What we have observed in Poisson ratio or in this configuration, that is, when one component is subjected to tensile load in longitudinal direction, other two perpendicular direction, the component has reduced its dimension. That is, from this concept we can write that epsilon x is what? 1 by E. Due to sigma x, its dimension will be increased in x direction, and due to sigma y and sigma z, the dimension of the component will be reduced in x direction. What will be that reduction? That will be mu into sigma y plus sigma z. I am not going to the derivation of this equation that you have done in class 12 level. I am just writing, and I have given the fundamental behind this. That is, due to sigma x, the dimension in x direction is increased, and due to sigma y and sigma z, dimension in x direction is reduced, and that's why they are minus sign. And how much it will reduce? That will be multiplied with mu by the definition of Poisson ratio. Similarly, other two equation comes. So epsilon x is 1 by E sigma x minus mu sigma y plus sigma z. Here epsilon y is 1 by E sigma y minus mu sigma z plus sigma x, and here epsilon z is 1 by E sigma z minus mu sigma x plus sigma y. So this is called generalized Hooke's law. Now we have studied three elastic constants, that is E, G and K. Now what is the relationship between them? We know that E is 2G 1 plus mu, which is equal to 3K 1 minus 2 mu. Now what is relationship between E, G and K? That is E equal to 2G 1 plus mu. So from that we can write 1 plus mu is E by 2G, or we can write 2 plus 2 mu is E by G. And from here E equal to, say this is equation 1, E equal to 3K 1 minus 2 mu. From this we can write 1 minus 2 mu is E by 3K, and this equation, say equation 2. Now add equation 1 plus 2, add equation 1 and 2. What we will get? That is 3 plus 2 mu minus 2 mu will be cancelled. 3 is E by G plus E by 3K. That is, from this 3 is E 3kg 3k plus G. That is E equal to 9 kg 3k plus G. So this is the relationship between three elastic constants. So what we get? That is E equal to 9 kg 3k plus G. So this is the relationship between three elastic constants, and this is the main relationship with E and other two, that is G and K. Now let us solve one problem. A circle of diameter 50 mm is scribed on an unstressed steel plate of thickness 10 mm. Thickness is 10 mm. So T equal to 10 mm as shown in the figure. Forces acting on the plate cause normal stresses. Sigma xx is 100 MPa. So sigma xx, that is stress in x direction, this is x direction, 100 MPa. And stress in y direction, that is sigma yy, is 50 MPa. Sigma yy is 50 MPa. Determine the change in the length of diameter AB and CD. Two diameters are there. This is AB and this is CD. AB, AB, AB is along x direction, whereas CD, CD is along y direction. Next, the change in the thickness of the plate. That is, what is the change in thickness of the plate? And thickness T, which is along z direction. Also, you have to calculate the volume of the plate. Assume E equal to 200 GPa and mu is 0.3. Now to calculate the change in length of diameter AB, that which is in x direction, and diameter is given, that is 50 mm, we have to calculate what? If we can calculate the strain in x direction, then we will get the change in diameter of the circle along AB. If we calculate epsilon y, that is strain along y direction, we can calculate the change in diameter along CD. And if we calculate sigma z, that is strain along z direction, we can calculate the change in thickness. So first of all, we have to calculate these three parameters. Now let us calculate epsilon x, epsilon y and epsilon z. So epsilon x is 1 by E sigma x minus mu sigma y plus sigma z. Now here, what is sigma z? Sigma z is 0. Sigma z is 0 here because vertical to the plate there is no force. Sigma z is 0 here. What is E? E is given 200 GPa, mu is 0.3. 1 by 200 into 10 to the power 9 as it is in GPa. Sigma x is 100 minus 0.3 into sigma y is 50 into 10 to the power 6, because these are in MPa. That is, this will be 100 minus 15, 85. So 85 by 200 into 10 to the power minus 3. 10 to the power minus 3. That is 0.425 into 10 to the power minus 3. So this is epsilon x. Now what is epsilon y? Let us determine what is epsilon y. E y minus mu. Now let us put the value 200 into 10 to the power 9. Sigma y is 50 MPa minus 0.3 into 100. This is 0. Sigma z is 0. This is also 0. It was 0 into 10 to the power 6. Now 50 minus 30, that will be 20. 20 by 200 is 1 by 10. That is, let me write down, 20 by 200 into 10 to the power minus 3. That is 0.1 into 10 to the power minus 3. Now, what is epsilon z? Let us first calculate all strain values. Z minus mu epsilon x plus epsilon y. Z is 0, that is 1 by 200 into 10 to the power 9 minus 0.3 into 150 into 10 to the power 6. That will give you what? 45 by 200 minus 45 by 200 into 10 to the power minus 3, that is minus 0.22 0.225 into 10 to the power minus 3. So we got all three direction strains. Now change in length of diameter AB, say delta AB, that will be what? That is nothing but epsilon x into phi d. What is epsilon x? Epsilon x we got 0.425 into 10 to the power minus 3, and phi d was 50 mm. So that gives us 0.2125 mm. So diameter AB will be elongated by this much mm. Now change in diameter of CD will be, CD is along y direction, so epsilon y into phi d, that is epsilon y we got 0.1 into 10 to the power minus 3 into 50, that is 0.005 mm. 0.005 mm. Now the change in length or change in thickness. What is change in thickness? Change in thickness is, T was the thickness, so change in thickness, say delta T, that is thickness is along Z direction into T, and epsilon Z is what? Minus 0.225 into 10 to the power minus 3, and thickness was 10 mm, that is minus 0.00225 mm. Minus this negative sign indicates that thickness has been reduced by this mm. This 2 has been increased and this thickness has been reduced by this mm, as there is a negative sign. So we have determined A and B. Now next in C it has been asked the volume of the plate, change in volume of the plate. What will be the change in volume of the plate? That is, E is what? Volumetric strain is epsilon x plus epsilon y plus epsilon z. Now put the values, that is 0.425 plus 0.1 minus 0.225 into 10 to the power minus 3. So E becomes 0.3 into 10 to the power minus 3. Now E is delta V by total V. So 0.3, that equation gives 0.3 into 10 to the power minus 3 is change in volume that we have to determine. And what is the volume of the plate? What is the volume of the plate? Volume of the plate is, in two direction dimensions are 100 mm. This is a the 100 mm 100 mm by 10 mm plate. So 100 into 100 into 10. So delta V, from this equation delta V becomes what? Delta V is 30 mm cube. That is, change in volume is 30 mm cube. Change in volume is 30 mm cube. So we have determined all the questions and we have solved this problem.